Good afternoon, everyone. I hope we had a decent time at lunch. Um, we'll spend a couple of minutes just going through some of the peering terminologies that you've encountered, not only here, but you'll also encounter as you go out into the world and start doing more peering. And the terminologies are really just to help you get an understanding of what folks are talking about when they talk about peering, and just to help you understand what folks are saying, not only here but also when you go out. So I think previously in the peering game, you heard a lot of terminologies. We'll try and go through those. We'll also look at some of the more common ones that you find in the field. Some of them will be related to peering. Some may be related to functions that support peering. Okay, so we'll get right into it. I've just put down a list of more typical, more common ones in alphabetical order. I'll just try to keep them as generalized as possible for those of you who might not have any previous background on these. So, for types of peering, there's bilateral peering, which basically tends to mean a peering relationship set up between two networks, the opposite of which is multilateral. We shall see that ahead. In data centers, facilities where we put equipment and put our networks, our infrastructure on the servers and stuff, carrier-neutral facilities tend to be those where customers are free to purchase network services from other providers inside the facility. Some facilities force you to buy network services from them. Those are not carrier-neutral. Carrier-neutral in this case means that you buy colo space from them. You can also buy network services from another provider that does not own the facility. Routing, cold potato routing, essentially a situation here where the network tends to retain the traffic on their backbone for as long as possible for a number of reasons, right? Could be quality reasons, could be billing reasons, and so forth. The opposite of that is hot potato routing, which we shall see later on. We talked about data centers and co-location. Typically, a data center is where you would house your equipment and your infrastructure, and the term colo, it tends to be short for co-location, and that's what you will normally hear in the wild. Looking at fiber, dark fiber tends to be normally fiber pairs offered by the owner of the fiber to somebody else without any equipment being attached to that fiber. The opposite of that is lit fiber. So somebody gives you a pair of fiber from point A to B, and they don't put any equipment on that. But it's not your fiber, you still lease it at some value. Data center, what is that? A purpose-built facility that provides space, power, cooling, and other network facilities for customers hosting equipment in those facilities. Demarc, short for demarcation. When you want to peer or you want to connect to a provider in a data center, they'll say, could you please send us your demarc information? And this would mean maybe stuff like, what's your rack number? What's your port number? Do you have a patch panel? Do you have a meet me room? Do you have a meet me rack or whatever? Those kinds of details, they would say, send us your demarc information. And that's what they mean. Okay? The default free zone. Default free zone typically means that service providers run their routers and they get a full BGP routing table from their providers, from their upstreams and so forth. Essentially, it means that they do not carry a default route inside their routers, which means that they have a complete view of the entire internet. Okay, that's what default free. It basically means that my router is free of the default route, hence default free zone. To depeer, I think you heard this term in the previous session. It's a situation where a network decides to terminate a peering relationship with another for one reason or another. Okay, so you peer with the network today, and tomorrow they say, I don't like you anymore, I should disconnect from you. That's de-peering. which is the opposite of peering. Downstreams tend to be typically our customers. Okay, there's other terms for those as well, but in this case, typically a network's customers would be called downstreams. They might also be called eyeballs. So eyeballs, basically the users of a network that are requesting content from some part of the internet. So those are the eyeballs, right? Facilities could be synonymous with data center or colo site where you tend to house infrastructure. A full circuit basically means a link provided by a network service provider on an end-to-end basis. So if you talk about networks between two different countries, you have a provider in Ghana that says, I should give you a connection all the way to the border with the neighboring country. So that's a half circuit, which is the one below. A full circuit will say, Ghana Telecom will say, I should give you a circuit from here all the way across to Nigeria, for instance. That's a full circuit. In a half circuit scenario, it's your responsibility to arrange the other half of the circuit plus this half of the circuit. So full circuits normally tend to be cheaper logistically and financially, but not always. We saw cold potato routing earlier. This is hot potato routing. In hot potato routing, the network wants to keep the traffic off its network. Okay, so the moment the traffic hits the network, the traffic needs to get off as quickly as possible. So the shortest exit off the network tends to be hot potato routing. Again, this could be normally because of cost. If you hand off the traffic at the closest exit, then you don't have to pay the money to keep it on your network, right? Interconnect charges, so these are basically monies paid by peering parties for the interconnect. It could be the cost of cabling, it could be shared facilities and so forth, okay? IPLC, International Private Lease Circuit, is basically a lease line that spans 2 or more countries. Looking glass. Many of you have probably heard this one. It's a device or resource that permits anybody interested in viewing how the world sees their network, okay? I think most of us might have heard of route views or know of route views. That tends to be a looking glass. You can also have a similar device at an exchange point and then have a view of your network from the exchange point. So it doesn't have to be an international device. It can be a local device. Some networks have that also as a way to give potential customers insight into their network, okay? It's a way to help sales. We saw dark fiber before. The opposite is lit fiber. In this case, the fiber provider leases bandwidth to you, and you cannot drive the fiber. The fiber is driven by their network, and you just buy capacity. This tends to be least preferred if you have the option for dark fiber, okay? Types of peering. So we have mandatory peering. In this case, members are forced to peer with each other at the exchange point. It could be the exchange point policy, could be government policy, and so forth. Basically, it's mandatory. Meet me room. A meet me room is in a colo facility or the data center, is a central location, normally composed of passive infrastructure where cables interconnect. So you rent space in a facility, you have pre-laid cable from your rack to the meet me room. If somebody else wants to connect to you, all the provider does, all the data center does is run a cable from your partner's rack to the meet me room. So that's sort of like a half full circuit type arrangement, right? That tends to be cheaper if you're looking at grooming a large amount of fiber. Multilateral peering. So peering with a group of networks through a single negotiated policy. This tends to be normally implemented by route servers and so forth, okay? Peering policies, so having no peering policy in this case, network implements the general policy in that they're not interested in peering with any other network. Okay, we should look at other options like open and selective and so forth. Off-net traffic, so traffic that is handed off to another network at some point in its flight. Okay, so it's typical. Small ISP here buys IP transit from another ISP locally in Ghana or maybe in the UK and so forth. So the moment traffic from your customer leaves your ISP and goes to another ISP, it's now off-net traffic. On-net is the exact opposite. Traffic remains under the control of the same network for as long as possible, sometimes until the end. Okay? There are normally quality issues associated with this. Some networks like to say all your traffic will be on net for 85, 90% of the time. Okay? An open peering policy is one where a network is generally happy to peer with pretty much anyone. Okay? Paid peering, similar to IP transit, but in this case, network is willing to pay another for access to its backbone. In this case, its customers are not necessarily the whole internet. Maybe its customers, some of its peers, and so forth. So it's not really IP transit, but it's still peering, but maybe you're smaller than the other guy, and it's cheaper for you to do that than actually buy full transit. A peer, we know, a network with whom you need to exchange traffic. And obviously, peering is the act of exchanging traffic with a peer. Peering coordinator, somebody who is dedicated to the process of peering and coordination of peering inside the network. Normally an underutilized role, but you find that as your network begins to expand, the role of a peering coordinator tends to become much more useful and visible. Peering policy, set of guidelines by which network operators will peer with external networks. The policy could be written, could be on the website, could be on any kind of media. You basically direct your peers to the policy and say, this is what I need to do, or this is what you need to do to peer with me. You need to be in 300 locations for me to peer with you, for instance. Okay? Points of interconnect, a location mutually agreed upon between peering partners in order to peer. So they could say, oh, okay, I should find you in this exchange point, and if you can meet me there, we can peer. Okay? Private peering. So peering that doesn't typically occur on public exchange points. So this is normally back-to-back peering between ISP A's router and ISP B's router. The private peering could be for a number of reasons. The exchange point doesn't function. You need more bandwidth, and so on and so forth. Public peering is the exact opposite. So this is typically what we have in Africa at the moment. Done across public exchange points is cheaper, especially if you have small amounts of capacity to exchange. Restrictive peering policies. In this case, networks implementing this policy normally not too keen on peering with others, but if you convince them sufficiently, they might open up. Okay? Route registry, a centralized database that contains routing information. So what most of the providers will do is they will source information from the route registry to compile their filters when they do stuff like BGP updates for their customers, and so forth. It's easier than manually putting that information into the router. Does it scale well? Maybe, maybe not. I think next time I'll put RPKI in there as well. Route server. So route server, centralized routes at a public exchange point that normally allows you to implement multilateral peering. So in this case, exchange point has 400 members. You need to turn up 400 peering sessions. It's too much work for you. Just peer with the route server, and you're good to go. Not all members will want to peer with the route server. Most might. Okay? Selective peering policy. Normally, a network would be happy to peer if you can meet a minimum set of requirements, meaning that you must have at least a 10 gig backbone, for instance. Okay? Or, again, you must be present in at least 2 different continents, for instance, okay? SFI, also known as settlement-free peering. In this case, neither party pays the other for the exchange of traffic. This tends to be the case at most public exchange points. Settlement-based peering, on the other hand, is what we talked about, for example, private paid peering is one example. In this case, the network pays the other for the exchange of traffic. Traffic ratios basically balance between how much traffic a network sends to its peers versus how much it receives. Some networks will say, I will peer with you if the ratio of the amount sent and received is just about the same. Okay? Transit, in this case, a service where a network pays another for access to the global internet, tends to be typically the case for a number of installations in Africa in this case. Transit free, I think Bill talked about this in the morning, and he said these are what they typically call the tier ones. They don't pay anybody for transit. Okay, so they have a full view of the internet, and they don't pay anybody for it. Upstreams. Remember we talked about downstreams. Upstreams typically networks to whom you hand off traffic for a fee. So these would also be your transit providers and so on. Okay, so if they say, oh, that's my ISP, that's my transit provider, that's my upstream, those tend to be synonymous. Oh, that's it.